Oh, hello, in this video I'll show you how to upgrade one of these IKEA air quality sensors with ESPHome for your home assistant setup, but not just particle count. I'm going to add a bunch of other sensors too. First of all, let's get into the IKEA sensor itself. So I'm just going to pop that open, take that out, don't need any of that. These are 4 Phillips head screws. I don't have a screwdriver that's small enough, so my little terminal driver does the job. There's always one. Okay, we'll keep those. We might need those again. Inside, it's quite simple. We've got the sensor unit itself with its intake, and then underneath, this just slides out. Underneath, you can see there's a little fan that just spins around. So it sucks air through the top, blows it out the bottom, and both of those intakes and outtakes are at the back of the unit. Let's disconnect this. And we'll put both of those to one side. Now on the board, we've got a row of connectors here. Got a connector there, we're not interested in that. We're interested in these 5 pads here. In particular, we've got plus 5 volts that comes in from the USB-C connector. Ground, which is the next one in. Then the only other thing we need to worry about is this pin here, second one in from the end. It's called rest, but it's actually RX from this pin here, which is the actual sensor. So let's attach some wires to these. Onto that board now, so I'm going to add a red, a black for the power, a blue for the data that's coming off of it, and a brown. So we'll get these soldered up. And as always, I am going to solder. I'm tinning the whole wire, but I want to leave a little blob near the base of the cut off there, because that's where I want to solder from. The rest of it's going to be cut off anyway. So we'll just heat up the wire and just try and leave a little blob. It's not necessary. It just makes it a lot easier to do that. And so we'll trim those off. Next up, we're going to add some solder to the pad. So the first one there, that's 5 volts. So I'm just going to put a nice blob of solder on there. Not too much. Next one in there, that's the 0 volts. We'll have one on there. And then the rest one there, that we pointed out earlier on. And then spinning it around, there's a couple of connections there for the fan. Now the fan's controlled by a MOSFET up here. And this is an N-channel MOSFET. So it's controlling the 0 volts of the fan. I'm going to put a wire on that second pad there where it says fan minus. Let's put a blob of solder on there. Right, attach the wires. First one is 5 volts, and obviously that's going to be red. Black one next to it, which is the 0 volts. And then for that data, I'm going to use blue. I'm just going to come off of there, and I do not like that connection, so we'll do it again. And then that fan there, I'm going to use brown. Bend the wire up just to get a bit of an angle, so I can push down from above the board, and that sticks there like that. So that's the main function of the air quality sensor. However, if we take the board off, and it's just 3 screws there. So we've got the 6 LEDs, which gives you the 2 green, 2 orange, and the 2 red. Above that, you can just about see it there, there's a little sensor. And that is a light sensor, and this board uses it to dim these LEDs at night. So why not use that? So this little sensor, it's got a supply on this side, and then over here is a voltage out. And we can use that on a D1 Mini. So I'm going to add a little bit more solder on there, and we're going to attach a wire to that. So very carefully, because it's a surface mount component, and you don't have to do this. It's on there, so I thought, well, why not? So I'm just going to, as I say, very carefully, I'm going to put some solder on my tip of my iron there, and then I'm just going to hold it very quickly, just little quick bursts, and then just dollop every now and then a bit of solder on there. So hopefully you can see there, I've got a nice little dollop of solder on that side. It hasn't lifted up the component, so we're good to go. And we're just going to add a wire to that. I'm going to add a green wire, but I don't want to add it directly. I want to put a 10k resistor just to drop the voltage down for the D1 Mini, because it only likes about 1 volt, and I found that a 10k resistor just drops that voltage down a little bit. The resistor there is brown, black, orange. That's a 1, a 0, and 3. So that's 1, 0, 0, 0, 0, 10k. So on one side of the resistor, I want to solder all the way up to the body itself. So I'm going to put a blob of solder there. That's where my wire is going to go. And then we need a little bit extra to come off of that board and just to come out of there. So I'm going to cut that off about there. So that was about halfway down that leg. So put a blob of solder on the end. And then that's probably a bit too much solder, so I'll just take some of that off. As long as it's tinned, that's fine. Bit of solder on my iron. And then what I'm going to do is I'm going to rest that wire on top of that solder blob that we put on the board, and then using my iron, I'm just going to push down on the wire itself just to melt the solder, so the heat will go through the wire, melt the solder underneath, and that makes a nice connection there. Okay, so we can cut this bit off here. We'll attach our green wire to it, so another blob of solder on there. Same thing again, nice and quick. And then we'll put a little bit of heat shrink over there, just to make sure it doesn't heat anything. And then with a lighter or some sort of suitable heat source, heat that on there. I don't want to go too far, I don't want to melt the sensor, so as long as the resistor's held and the wire's held in the heat shrink, that'll be fine. So that's the sensor board done. We can put this back on here now. Let's clip on this side, so I'm just going to put that underneath there at a slight angle because of that wire, and then I'm going to use the screw there just to hold that wire on. Right, now these screws are really fiddly, and my big old sausage fingers. It's the old trusted tweezer, like so, and then finally that top one there. Red, black, blue on those pins. The blue one's going to the rest there. We've got the brown wire coming off that fan minus. And then finally, we've got that green wire there connected to our sensor, which is on the front of the device. We could stop there. We've got some space in that case. So let's add some more sensors. So let's put this away to one side and we'll talk about those. The other sensors I'm going to add, this is a BME or BMP 280. This will give me temperature, humidity and pressure on an I2C bus. And then the other one I'm going to use, this is actually called a CCS811. And again, this is an I2C unit. And this is handy. I'm not sure if it's the same with all sensors. But if I line those two up, like so, you can see VCC ground, SLC and SDA are in the same positions. So I can stack these on top of each other. And to do that, I'm going to take one of these 8-way sensors that come with the D1 Mini. I'm going to break it in half. And then on one of them, I'm just going to pull the pins out. Get rid of that and that and that. And I'm going to put that on top of the longer pins. So let's get the right way out, Dave. There's a little indentation there. Same was there. So we're going to line those up as well. And then on the desk, I'm just going to push those down. So I've got a double-sided one in the top of the CO2 sensor. I'm going to put it that way round. Then I'm going to take the BME and we'll put it on top like that. So let's solder that together. So as you can probably tell, that's all a cattywampus, as they say. So what I'm going to do is I'm going to solder this first pin, give it a nice lot of heat because I've got a pin there which is quite thick, and then I'm going to solder the other side on the top side here. Won't need so much heat because that pin's already heated up a little bit now. And then as you can see, that's a bit nasty, that is. So using my fingers, and I'm just going to pull this that way while I heat up this pin at the bottom, just to straighten that up there. And we'll do the same for the top. So I'm just going to use my middle finger there to lift it up. Use my nail to keep it from coming off the pin. And I'm just going to slowly move that up so they're roughly parallel. Now they're all in line, I can solder the rest of the pins. Okay, so that's all soldered, top and bottom. And let's throw it on the floor, Dave. Right, so that one's soldered, top and bottom. We need to add our 4 wires for our supply and data. However, the CO2 sensor needs one other connection, and that's that WAK, which is wake. That needs to be connected to 0 volts. So I'm going to run a black wire from this wake pin here to the ground at the top. So a bit of wire, we can put that off there, and I'm going to put that through the boards like so, and then I'm going to solder that in there like that. And then, as always with wires, I'm just going to straighten it up by reheating it, reflowing the solder. So that one's done. I'm going to cut that off. As I say, this one needs to go to 0 volts, so I'm going to come this way around and pull the wire a little bit there. Then using my nail, I'm just going to stop that so I can bend it. So we've got a nice little right angle there. And then I want to come off a little bit, so a couple of mil, 1/8 of an inch for my American cousins. And obviously I'm using silicone wire there, so I can cut that off with my nail, which is quite nice. You'll find a link in the description for an Amazon listing of the silicone wire that I actually use. I use 24 and 26 gauge wire. That's the AW gauge, I think it's called. I've tinned that. I don't need that much wire, so I've got like a millimeter or so, and then I'm just going to bend that there and connect it to my ground. Try and touch the wire and the pin together, and then we've got our connection. And then we can just simply neaten that up a little bit, just to keep that reasonably tidy. That'll do. Now let's add the wires to this that I've got to connect this to the D1 Mini. Obviously I'm going to use a red and a black for the supply, and I'm going to use a white and a yellow for my I2C. So these don't need to be that long, a couple of inches. I'm going to cut these down anyway. And again, we'll trim all these off, get them tinned. Let's just get their center out of the way so we don't blob a load of solder on it. So we've got very short stumps at the size of the pads, of these things. So working away from the bottom, I'm going to miss one. That's their extra black wire that we added. So I'm going to use the second one up. That one's going to be a white wire. So it might be a little bit awkward, but I want the wires coming out with the sensor that way. I'm going to turn it this way round, and I want these wires to come out of the right. Next one up is yellow for the second data. The next one up is ground, and the last one is the supply. And who can guess what color I'm going to use there? Leave a comment below if you guessed right. #interaction. That's our sensor board done with our IKEA sensor done. Next thing we want to do is we're going to connect both of these to our D1 Mini, and we'll start flashing and get it working. Now I'm not going to use any pins on this. I'm not putting it on a Vera board. I want to make this as low profile as possible just to keep that airflow in the case. I'm going to tin up the pads that I'll be using on this board. Also, I'm going to be using the 5 volts and the grounds for the power coming off the IKEA. So I'm going to tin this side on the bottom. I'm also going to tin the other side as well. So I do need some more connections on this. And I'm going to be soldering wires to both sides of this board. So back on the bottom, I'm going to solder our D4 A0. Nice big blob of solder on there. Thank you, missus. And then the only other one I want on this side is that D7. Right, that's the pads done. Now, it's going to be a bit tight there with the wires hanging off the board. So we've got another couple of ground points here. This is the case for the USB connector. So it's all 0 volts. So I'm going to put a blob of solder on one of those so I can add my black wire to that one instead. This will take a little bit more heat, so be patient. Grab our IKEA board. So the shortest wire there is that brown wire. So I'm going to cut all of these so they're roughly the same length, and let's connect these two together. So first of all, let's do the red, and then this one I want to do it at a slight angle. We can get in focus. We can get in focus there, camera. Be much appreciated. So a slight angle. Come off of there, like so. As I say, black wire is going to come off of there, and that's going to be a little bit shorter now because it's closer. So what I'm going to do is I'm going to spread this out, and let's see where that wire goes. So I'm going to pinch it there, leave a little bit for my tinning. We'll cut it off there, pinch that off, and I'm going to try and make all these wires roughly the same length for the space that I'm going to use them in. Let's go the other way here, and then that one's going to go on that pin there. So again, slight angle coming off of that one. Next on this side, we're going to do the blue wire. That's going to go to our D7, which is the bottom one there. So same thing again. I'm not pulling it, but I am pulling it enough just to get these wires nice and straight. And then we'll line that up, and that's pretty much where I want to be anyway. That's the length of wire. And we'll just tin that blue wire there. I'll say that one's going to go on D7. So round we go again, because I'm left-handed. Don't want to have it in line with that next pin. We want to come in at a slight angle, so about 45 should be safe. Next one on this side is the green wire. Now, unfortunately, that looks like it's not going to be long enough because I've made the other ones too short. So, okay, I tried. It's not critical. I'm just trying to be neat here. So this green wire is coming off that light sensor on the front of this board, and that's an analog signal. So that's going to go into the analog 0 pin, 45 degrees roughly. Just so it's not covering pads or any other pins underneath. It should be fine. And then finally, we got that brown wire coming off the fan connection, and that's going to go into D4. The only reason being, really, I mean, it gives you an indication in Home Assistant that the device is taking a sample. I'm using D4 because that's the light on a D1 Mini. And I want the light to show up when it's sampling. I mean, you're not going to see it, it's going to hang out the back of the case, but, you know, it's there. We can use it. We can use it. Why not? I mean, these things are quite powerful, and I'm not doing a lot with it, so we might as well use all the functionality that we've got available to us. So there we go. That's the sensor array from the IKEA going into the D1 Mini. And you can stop there, but I'm going to add our extra sensors. And that's our little stacked board there. Now, this doesn't need to be that long. It doesn't need to be that far away. Let's cut all these wires down. About an inch, inch and a half. Not critical. You can leave it a little bit longer if you want. I don't think these wires are going to restrict that much airflow inside that IKEA case. It'll still be able to sample. And we're going to tin all of those now. And I'm just going to snip the tip. Now this one I'm going to put on the top side of the board. And it should make it a little bit easier. I don't want too many wires crossing each other here. I'm going to cross them in front of the actual chips that make a difference on a D1 Mini. It's D1 and D2. I'm going to put them on first, because these ones will not be getting cut down. White wire here, as per the code I've used anyway, that goes on D1. Yellow wire on D2. The 0 volts goes on the ground over here. And then the red wire, I'm going to cut that down. So again, not got too much in there. And then we'll connect that up to that 3.3 volts on that side. Okay, so that's the hardware done. Let's flash it with ESPHome and I'll talk you through the code that I'm using. Let's make a new device in ESPHome to load the code to. That continues there. I'm going to call this one Studio Air Quality. Don't really care about any of this, so we'll just do the basic stuff. Skip that. Then let's edit this. Then we're going to go to the GitHub page. You'll find a link in the description. And this first sensor here, we want the version 1. So click on that. Over on the right here, we've got copy raw file. Copy that. That's going to copy that into my clipboard. So we go back to ESPHome and then just Control V that into there. First thing you need to do is whatever you've called yours, we're just going to copy that out of there and replace that with that name. And then all we need to do now is change the name. I've called this one AQ for Air Quality, and I'm putting this one in my studio. So all my entities are going to be called Studio AQ and then whatever the entity is showing. So temperature, humidity, particle count, etc. So standard boilerplate here. If you're not using secrets, put in your Wi-Fi SSID and password for that. The logger, I've disabled these sensors and components just so I can unclog the log. Next up is the UART. That is the serial port, and that's the blue wire on this board that comes into the D1 Mini on D7. I've left the TX pin on there. We're not using it. It's just there as a reminder. Next up is the I2C port. That's the sensors here. That's the temperature, humidity, pressure sensor, that little board at the top there, and the CO2 and VOC sensor on the bottom there. That's D1 and D2, which is our 2 white and yellow wires on the D1 Mini. Next up is the binary sensor. Now coming in on D4, which is that fan connector here, that's just an on and off. So I'm basically just doing a binary sensor, and this uses the substitution there, which is Studio AQ. So this comes into Home Assistant as a Studio AQ for air quality, and then the fan. And that just gives us an indication that the fan is on in Home Assistant. And because it's on D4, it lights up the blue LED on the board, which is nice. You can never have enough blue LEDs. The other binary sensor is the brightness. So this is, again, using the substitutions, Studio AQ bright. And this is just going to be on or off, depending on whether that sensor on the front of the board there that we connected the green wire to. And that's just detecting whether it's bright or dark. And we're bringing that into Home Assistant. You can use that in various automations for a brightness or a darkness of the room. Next up is the sensors. We've got the particle sensor itself, the PMS. That's on that board there. And that uses the serial data from the UART there. Substitution, 2.5 microgram. Next sensor is the CO2 and total VOC sensor. That's that larger board at the bottom there. And that comes in, again, substitution name for CO2, substitution name for VOCs. Now this board also likes to have a temperature and humidity, just so that the CO2 and the VOC have got a baseline for the environment that it's sitting in. So it gets a nice temperature and humidity settings there. So we bring those in. This here, BME temperature, that's the ID for the temperature sensor of the BME, and the same for humidity. That's the ID I've called that. The calibration, we'll get to that after I flash this, and I'll show you how to calibrate that. That's the calibration for the CO2 and the VOC sensor. And then the BME sensor itself, pretty much boilerplate here. We've got the substitution name for temperature, humidity and pressure. Also, both of these sensors I've set to 10 seconds update. And then the last thing we got here, again, with that brightness sensor on the front of the board, that comes into the ADC of the D1 Mini, which obviously is the analog port there of A0. Now, I've given this an update of 1 second, so your automations are fairly snappy. This is not the best sensor in the world, so don't rely on it, but it does give you an indication. And we don't really need to see the voltage coming out of this ADC. So that's, again, on the sensor there, we don't see that data. So I've given you an additional log there, and it just gives a light level of the voltage on this sensor. We don't really need to use that because we've got the binary sensor to tell us whether it's dark or bright. That's what that little lambda does there. We're looking at the value of X. X is an internal variable for the sensor that it's attached to. So in this case, this is the ADC sensor. So we're looking at X, and we're asking if X is greater than 0.01. If it is, we're going to turn on or publish state true bright. And bright, look up here, that's the ID for this binary sensor that we've called bright. So when the light level coming in that sensor, or the voltage coming off that sensor, gets above this threshold, it's going to publish the state true to that binary sensor. Otherwise, or else, it's going to publish state false, which basically means it's going to turn on and off this brightness binary sensor. Right, so that's the code explained. Let's install it. And this is the first time I've installed this one, so I'm going to do a manual download. Okay, that looks like it's almost done. 155 seconds. So I'm going to save that to my desktop, overwriting the one that's already there. Yes. Right, that's done. We can close that down, and we can close that down. I'm going to minimize that for a second, and let's bring up the ESPHome flasher. So that's ready. We're going to plug this in. You may have already noticed that the round wire here has been disconnected. I've taken it off the fan minus on the IKEA board there. I found that some of these D1 minis don't like the D4 connected. Even though that's a floating pin, there must be some sort of voltage creeping onto that fan minus pin there. If you have trouble flashing yours, if this stage doesn't work, just disconnect that round wire there. So do a quick doobly-doo, let it find the D1 mini. There it is. COM3, hang on there, browse, and flash. Alright, there it goes. It's scanning the Wi-Fi. Looks like it's connected. So close that down. Let's go back to ESPHome. Scroll down. We should see that online now. If we go to logs, we should see some data coming in. So there we go. Quick sanity check. We've got 2 I2C devices found on the addresses there. So we can close that down. We can now disconnect that. And I'm going to solder this brown wire back on now. Yep, so that brown wire's back on there. Let's glue this into the case. Now this is quite shiny, so I'm going to make some scores here just so the hot glue has got something a bit more to grip onto. So I'm just going to scratch the hell out of the inside of this case. So I'm going to do some horizontal, I'm going to do some vertical scores, I'm going to do some diagonal scores. Just really go to town and make sure we got some deep scores there. And then the same for this side where we're going to put the sensor package. And we'll tap that out. I'm just going to brush everything out. Obviously this is a particle matter sensor, so I don't want too much dust inside here. So we'll give that a good clean, and let's tidy up the desk. Let's get rid of all this detritus. And it's all over me. Nice. We're going to line up these wires just so they're reasonably flat like that. And I'm going to put a nice big blob of hot glue in the center of here. Then we'll stick that to the top of our case. So pretty much all the way down in the center, like so. And we'll just wait for that glue to set. And then our sensor package, we'll do the same thing. Let's grab our tweezers and put a nice big blob on there. Not that heavy, don't need a lot. And then I'm just going to grab that, and then we'll just hold that while that bit sets. With the fan outlet facing downwards, we can slide that over the rails there. We'll connect it up there. Then we'll push that one into there. Just make sure these wires here are not fouling that hole. I'm just going to bend them down just so that they're clear of that stand there where the screw comes down, and this post here. And then on the other side, I'm just going to pull all these wires down here just to get them out of the way. Right, okay, looks like I made a little bit of an error there. I've got a little bit of... So yeah, I've turned the light down a bit. You can see that it's not quite clear, and the reason being is this little post here is hitting my D1 Mini. So I'm going to snip the top off of that, because that's not good. And then that should now be on there flush. There we go. That's better. Plug the power back in. We should see it go through its calibration, where it's its little test in there, and then start measuring the particles. I'll turn that down a little bit. You see a little bit of flash. These lights are strobing. The camera's picking it up, but you don't really see that in real life. I'm going to wait for this hot glue that we used to stick the balls in to cool down completely, and then we need to calibrate the CO2 sensor by just sitting this on the windowsill in front of an open window, or in my case I'm going to hang it out the window for about half an hour, let that settle down, and then we'll get that base number so we can calibrate the CO2 sensor. Right then, back in Home Assistant, we can see I've got a new device. Let's check it out. That looks like something we've just made. So I'll configure that. Yes, I want to submit it, and I'm going to put this in the office. Now, if we go to ESPHome, we scroll down to Studio Air Quality, and we're just going to refresh that. Sensors don't come in straight away. So we can see we've got a particle count. The particle count is 400 for the CO2. We can see the fan going on and off. I think it's off for 20 seconds and on for 8 seconds. So every 20 seconds that comes on. We've got our humidity, pressure, the VOC, and the studio temperature. So let's test this CO2. I'm just going to breathe into the back of this thing. Yep, there it goes. So that's working. Now, this is not going to be a proper reading until we calibrate that sensor. And the way we do that, we go to ESPHome, we have a look at our studio quality. The first thing I'm going to do is go to edit, and I'm just going to uncomment that. And we'll flash that wirelessly. It won't take too long because it hasn't got to install any components or anything. We'll let that wirelessly flash and then wait for the logs. It's not ready yet. We'll just wait for that. It's every 10 seconds. So give it a little while. We'll start getting data in a moment. Okay, there we go. We've got the CO2 level and the VOC level. And you can see there, it's got a baseline of that. Now, to calibrate it, what we need to do is put our sensor on a windowsill behind an open window where there's nice clean air. Now, for me, that's going to be a case of putting it out the window, which I shall do now. Okay, so that's outside the window now in the nice, clean, fresh air. And we're going to keep an eye on that. So we're currently 302. Now that sensor will take about 20 to 30 minutes to calibrate. So I'm going to leave it hanging out the window for half an hour and we'll come back. Okay, 1 cup of tea and a couple of sandwiches later. And it looks like our baseline here seems to be 22 dB. So I'm just going to copy that out there. We'll go to edit. We'll scroll down to the calibration area. I'm going to paste that in there. And I'm going to uncomment that line. So what this is doing is giving it a baseline number that it's going to use to say at this value, the air is clean. And every time you boot this device, it's going to use this number as a baseline. So with that done, we can uncomment this now so that it doesn't clog the logs. And I'm going to refresh it. Right, that's back on the network and connected to Home Assistant. And if we go back to our sensor now, we'll just wait for this data to come through. And there it is. We've got a CO2 count of 400s. That's outside. So again, this is the ambient or quote unquote clean air. And looks like we've got some VOCs outside. So there you go. We've taken an IKEA sensor, which would normally just give one data point. We've added a few more. So yeah, that works. Well, I hope this video was helpful with your projects. Please do share it so others can find it as well. I upload videos whenever I can, so subscribe and hit the bell icon to get notified. That's it. Thanks for watching.
Okay.